Video 47. Problem number 4. Verify the validity of the following argument. Every living thing is a plant or animal. John's goldfish is alive and it is not a plant. All animals have heart. Therefore, John's goldfish has a heart. So, solution. Let the domain of X be the set of all living and non-living things. Living and non-living things. Let every living thing is a plant or animal. So we have to living thing. Let L of X is a living thing. And then we take P of X is a plant. X is a plant. So John's goldfish is alive and it is not a plant. All animals have heart. H of X has heart. That John's goldfish is a particular element. We take G for John's goldfish. Premises are first one, every living thing is a plant or animal. Every living thing, for every X, for all X, every living thing, for all X. This X refers to either a living thing or non-living thing. If you want to specify a living thing, if it is a living thing, then every plant or animal, P of X or plant or animal. So animal, we have not taken any notation for animal. We take A of X. Let A of X is an animal. So therefore P of X either a plant or an animal. So this X refers to, this X belongs to the domain. The domain consists of all both living and non-living things. If it is a living thing, then it is a plant or an animal. That is the first one. So John's goldfish is alive and it is not a planet. So John's goldfish, we have taken it as G. Is alive means L of G. It is a living thing and it is not a plant. Negation of P of G. So goldfish is living thing and it is not a plant. Okay. All animals have heart. For every X, for every living or non-living thing, if it is an animal, A of X, then it is a heart, H of X. So conclusion is John's goldfish has a heart. That is H of G is the conclusion. G goldfish has heart. So steps, reasons. Okay, reasons. First step, we take single element L of G and negation of P of G, premise. By simplification, 1 L of G and 2 negation P of G. Simplification from 1. simplification from 1. Third one, take the premise for every x, L of x conditional P of x or A of x. This is premise. This is universal generalization. We will go to universal specification. L of A conditional P of A or A of A for all A in the domain. This is universal specification from 3. So we have L of A and A of E. So we have L of G is there. G is one of the values of A. So what we can do is, for all E, in particular phi, A can be taken as G, L of G conditional P of G or A of G, by taking in particular A is equal to G. You will get this one. Already you have L of G. L of G conditional this. So using modus ponens, in 2, 1 and 5, you get L of P is there, P conditional Q, so you have Q, P of G or A of G, using modus ponens, either P of G or A of G. But as per 2, P of G is not true because negation P of G is there. So therefore you have A of G. This is using disjunctive syllogism in 2, and 6. It says either P of G or A of G is true, but P of G is not true because you have negation of P of G. So A of G is true. So let us take the next hypothesis. For every x, A of x conditional H of x. This is premise. Now we will go to, this is universal generalization, universal specification from 8. You get A of small a conditional H of A for all A. Now 10th one, by taking for all A it is true. So in particular by taking A equal to G, A of G conditional H of G. You have A of G. And A of G conditional P conditional Q. So modus ponens, using modus ponens in 7 and 10, you get H of G. This is what is required. Thus we get the conclusion H of G. So this completes the problem and also video 47.